Hello, I want to introduce you to SandState, a collaborative software solution for CTOs and engineering leads. And in this demo, I will show you 3 use cases of system design and architecture modeling that SandState can easily handle. In use case 1, we will see top-down design. By top-down design, we will see how can we model our architecture on canvas with interactive layer zooming, code representation, version control, and code comparison. In use case 2, we will see design integration. By design integration, we mean that we can easily design product increments in smaller pieces and integrate them back into the global architecture diagram. In the use case 3, we'll see how can we maintain our architecture up to date by reverse engineering our code and integrating this code into the global solution. Okay, let's start with use case 1. I prepared some 2 examples of marketplace. This is our system we can play with. And we see on the system design scheme our marketplace and external components like users and data warehouse marketplace operates with. And we easily can double click on each part of our scheme and zoom into its internal state. Inside marketplace we see UI and backend. These are internal components of our solution, and we can see external parts like users, data warehouse, and other systems we integrates with. Okay, let's plan our architecture and add new brick here. We say this is database, and database is used by backend. And we also add new connection from database to data warehouse. Okay. This is our planned architecture. And we can save this state in the current version. We can see that current version is 0 and we have no more versions yet. And we can save this diagram into the new version, version 1. Okay, let's do that. We saved this diagram in the new version, and we see that now we have 2 of them. And we can scroll our version and change it and see what changed from the previous iteration of our planning session. But beside that, we can compare them in code representation. By clicking on code representation, we see version 0, version 1, and we see what changed between these 2 versions. We added database and we added new connection to data warehouse. Okay, let's do something else, and we add new connection from user to UI. Yeah, this is logically for us. And we save it in version 3. Yeah? And in code comparison, we see changes between every versions. Yeah, we can compare version 1 with version 2 and see new connection from user to UI. We can compare version 0 to version 2, and we see all changes that are done from the very beginning. Okay, this helps us to keep our architecture and design under control and see changes incrementally by version controlling. Okay, now we going to use case 2, and this is design integration. Design integration is when we implement some product increments draw them on our architecture canvas, and they are integrated back into the global scheme. Okay, how technical leads or CTOs or solution architects plan new functions, new features? They usually start from scratch. Okay, let's do that. In our marketplace, we are planning to create some user customer service using modern techniques like RAG pipelines and answer their questions with chatbots. Okay, let's do this. We have our user, we have our chatbot, and this chatbot uses RAG pipelines, for example, RAG pipelines, and we have some LLM like OpenAI ChatGPT to answer user questions. And to store our knowledge, we should have also vector store. Okay, we have several bricks. Let's tie them together. User interacts with chatbot. Chatbot uses RAG. RAG uses vector store, and RAG also interacts with OpenAI ChatGPT. Okay, this is our product increment that we designed in brainstorming session. Let me save this. But how can we integrate this increment into our global system architecture? Because it's very important to keep global architecture up to date. And SandState can solve this question as well. With easily annotating each brick on this diagram, for example, I click user and tie it with the user in our global landscape. Chatbot is a part of backend. RAG is also a part of backend. Vector store is a part of database, and OpenAI is a new system and we cannot map it somewhere. Okay, that's done. And let's see how it is integrated in the global landscape. We go to system diagram and we see that in our system design diagram, new system appeared, OpenAI ChatGPT, and it is connected with marketplace, with our basic system we started with. Okay, and if we go deeper, we have internal connections. For example, backend operates with OpenAI ChatGPT, and if we go deeper to database layer, we have new component vector store, which was drawn in our draft diagram. And this is how can we keep our architecture up to date and give technical leads, solution architects, product managers freedom to diagram product increments on separate canvas. Okay, let's go further, and in use case 3 we'll see how can we keep our architecture up to date with code scanning, code analysis, and integrating code into our solution architecture. I will start with blank canvas. We see nothing here, no versions, no diagrams, and I launch crawling mechanism. Crawling mechanism is the tool that scans our code and turns it into architecture. Okay, we see that new system design appears. We double click on it and we see our internal blocks. We can also see the tree of our components. That system design has SandState application, it has backend and storage. Backend has its own internal components, AI systems, internal APIs, and so on. And going to these layers, we see internal parts of each of these layers. And each of these components has its own annotation, some metadata, descriptions. We can also flag it for some reasons. This code to architecture approach helps us to maintain our system design and architecture up to date. And even if code is changing rapidly every day, with every release, we have visual representation of our architecture up to date. By this demo, we showed how can we design our architecture top to down, how can we integrate product increments with smaller pieces into the global architecture diagram, and how can we integrate our code and changing our code in the global architecture diagram.